Hello, everyone, and welcome to this session on Silverlight in Windows Azure. I'm Matthew Kerner. I'm a program manager on the Fabric Controller team in Windows Azure, and I'm delighted to see so many people here at the very last session of the very last day of MIX. So kudos to you, and in return for your sticking it out all the way through to this point, I'll start off with just a little story about my first visit to Vegas. I was maybe 13 years old, and my family was on our way to the great national parks in the southwestern United States. We had a layover at McCarran, and we had an hour or two to spare. So my father took us over to the area of the airport with slot machines. And he said, "Children, I'm going to teach you a lesson about gambling." And he took a quarter, and he put it into the slot machine, and he pulled down the arm. We were all watching. And, you know, the things lined up, and then all of a sudden these coins started falling into the slot. He won about $5. And I was pretty excited. I wanted to take the money and put each quarter that we'd won into another slot machine and see if the same thing would happen again. And he said, "We're not doing that. We're getting out of here." And he took the money. We went and we bought an apple or something. And he, he'd intended to teach us this lesson, and I really learned two things from this one attempt to teach us a lesson. The first was that if you have a quarter and you want $5, you ought to put it into a slot machine and see what happens. And the second lesson is that when you do a demonstration, it sometimes does not work the way you expected. And so if during my talk my demonstration happens to go awry, I hope that you will bear with me. So let's begin. I'm going to be talking about Silverlight in Windows Azure, and I should put up my slides. So I think, the first thing, the first thing that I thought about when I thought about this talk was, well, these two technologies have very little to do with each other. One is this technology for building really beautiful UI. I'm going to have to stand on this side, it looks like, to use the clicker. To build this beautiful UI that's really rich, and it can run on a variety of different devices, from the phone to the web to the desktop. And so many of you, I assume, are already somewhat familiar with Silverlight. And then Windows Azure is this technology that allows you to host services on the internet without having to worry about lots of things that every service developer has to worry about, whether it's deploying, getting physical hardware, putting the OS on, and so on and so forth. And so these are really two completely different technologies. But my thought was, and the thought of many people that I spoke with, that if we can connect the dots between these two technologies and share just a little bit of Windows Azure with developers who already know quite a bit about Silverlight, it will enable them to focus on the stuff that they already know and that they love to do, thinking about their customer and the user experience, without having to worry about all of the nuts and bolts of running a service that, for most people is really just a distraction. So the goal today is to cover Windows Azure, to give you a brief introduction if you're not already familiar with it, and then to talk for a while about the patterns that we've seen when we've combined Silverlight and Windows Azure. And then finally, I'll close with a set of tips and tricks, and these are really simple things that if you don't know them, you can spend a lot of time kind of chasing little issues, and so I'll just tell you what those are, so when you get started, you won't have to spend the time figuring that stuff out. So that's the day. I'm not going to go extremely deep into Windows Azure or extremely deep into Silverlight. You may as well just get up and leave if that's what you're looking for. But I hope you'll stay because I think it'll be interesting. And so what I wanted to do is just show you a Silverlight running on Windows Azure. And Steve Marks is sitting here in the front row, and he went and built this really nice Silverlight app that he actually used during his talk. And so I'm just scrolling through it really quickly, and he had interesting things to say while he showed you this. And I think it's kind of a beautiful little application. He had quite a nice little thing going here, for example. So you can see this is this really nice experience with all these cool zoomy effects, and it's Silverlight, and it's hosted on Azure. And so really the question in response to that is, so what? It's a website. It's running Windows Azure. It could be running on an on-premises server, and it would be sort of the same end-user experience. So I tried to put myself into the brain of Steve Marks, as frightening as that may be, and imagine kind of what about this makes this a powerful demonstration. So there are a few things when I wear Steve's hat that I think about. The first is I didn't have to go provision physical servers, install the operating system, set up networking gear, ensure that I have physical security and a reliable power source. I didn't have to deploy my application, and I also didn't have to go to an operations team and negotiate to deploy my application. I just went to a website and did it. And I don't have to worry about watching that application to make sure that it's always running. I mean, maybe I do, but at the most basic level, Windows Azure is going to take care of all of that stuff for me. So I'm already not thinking about this basic level of busy work that I'd otherwise have to get done in order to just get this site up and running. So that's sort of the first thing that I think made Steve really happy. The second thing that I think made Steve really happy is that he didn't have to spend money to get going on this. I mean, he spent his time, but he didn't have to go buy stuff. And that initial capital expenditure can be a big barrier to entry, especially to someone who has like a cool new idea and they just want to try it out. And the beauty is he can take the money that he might otherwise have budgeted for that initial capital expenditure, and he can just kind of stick that bar on its side, and he can pay operating costs over a period of months or whatever. So he can try out his service. And if his service takes off, he can pay more and he can scale it right up. So he can grow incrementally. He can grow his costs as he grows his revenues, and he can grow his scale at the same time. So that's sort of the second thing that made Steve happy. The third thing that made Steve happy is that he can go to the website, and with a few clicks, he can get this same experience deployed in East Asia or Northern Europe or Central United States, and he doesn't have to go kind of negotiate the tax laws or find the right data center in each place. He just goes, and there's a drop-down menu, and he picks the data centers that he wants. So he has geo-distribution, and that's really easy. And if it becomes very popular, if many people want those zoomy effects, he can just scale up the number of VMs that he's running on, and boom, they're there. So he gets that. Now, kind of under the hood, we're building a ton of physical infrastructure in order to support this. So we build data centers that are very large and are power efficient. So we spend less money maintaining infrastructure than many other people would, and that means we can pass savings on to our customers, and, by having low costs for the consumption-based billing model that we have. And when we purchase hardware, we purchase it in bulk. We purchase servers in numbers that are kind of mind-boggling. So we get discounts. And that means that we can also pass those savings on to our customers while still being able to make a profit that enables us to innovate and do new things, which I think is good for everybody. So this is sort of another reason that Steve is really happy. And at the end of the day, Steve gets to focus on his customers and his user experience and his business. And he's not busy doing the same busy work that every service developer has to think about. And meanwhile, we make a business out of focusing on that and making it really great. And so you can spend less money and get more on the service management aspects of the job than you otherwise would. So now that I've shown you a Silverlight app running on Windows Azure, and I've talked to you a little bit about why that might be interesting, I wanted to describe what Windows Azure is. There are a few parts. I'm going to fit this on one slide. And at the end of that, I'll basically have covered everything about Windows Azure that I'm going to cover, and we'll start talking about patterns. So the first piece that most people experience when they use Windows Azure is the software development kit. This is available now for free to download. And so you can go and get that, and it includes all the libraries and all the tools that you need to create cloud applications and package them up for running. And it contains two particular pieces that I think are kind of interesting and are different from many SDKs that you might have used. The first is there's something called the development fabric. And the development fabric is a sort of a little service that runs on your computer that creates a simulated data center environment. So when you write a cloud service application, you can run it in the development fabric, and you can run many different role instances. I'll talk about what those are in a second. And you can kind of see how the app would behave in the data center, and you're just running it on your PC. And that's totally free. You can do that as much as you want. It's really quick to modify your app and rerun it in development fabric. So that's one piece that's part of the SDK that's unique. The second piece is something called development storage. Now, in the cloud, Windows Azure Storage is this highly available and scalable storage service that lets you store different kinds of data. You can also run that on your dev box and test and try out your applications locally. And there are three abstractions that Windows Azure exposes in the development fabric. The first is tables. These are not relational tables, but they're structured storage. There's one index. You can do operations on the tables, reading, writing, deleting the data. And so if you had, say, a list of customers or a list of products or a list of images or a list of videos, you could put that in a table. There are blobs. Those hold arbitrary files that you define. People use them for images or movies or music, binaries that other customers are going to download and install. So you could put those in blob storage. And then there are queues where you can enqueue messages and dequeue messages. So you might have a set of work items that you put into a queue, and you might pull those off in another place and work on them. And so all of that can run on your local dev box. And we also have something called the Windows Azure Tools for Visual Studio. And this is also free and available. You download it. It integrates with Visual Studio. And so you can create a cloud application inside of VS, hit F5, run it in the development fabric. And I will show you that in a few minutes. Now, once you have decided that you're ready to go to the cloud, you create what's called an application package. That application package contains two parts. The first part is your code, all your DLLs, executables, and other content. And then we have something called the service model. And the service model is a document that describes the service that you're going to put in the cloud. And that service model lets us automatically deploy and manage that service on your behalf. And because the service model is this sort of unique piece that differentiates Windows Azure from a bunch of other cloud providers, I wanted to spend some time on it. So allow me a short diversion to talk about the service model. The service model consists of three major parts. The first part is a description of the pieces that make up your service. So there are a set of roles, different functional pieces of code that do different things, and the interfaces that those roles use to talk to each other and to talk to the outside world. As an example, I might have two different roles in a service. I might have a front-end role that provides some user experience to customers who come to browse to my site. And I might have some sort of business logic that's at the back end that does some processing based on what users choose to do. And I can define what number of role instances I want for each role. And if those roles communicate with each other, I can define the interfaces that they use to communicate with each other. So here I've got a load-balanced external endpoint that goes to my front-end role, and then the front-end roles communicate through some sort of synchronous network protocol, TCP protocol, with the back-end roles in this particular example. So now I've got this picture, and that picture allows the fabric controller, the automatic data center manager, to allocate physical and logical resources to your service running in the cloud and automatically deploy them. And then you also describe some policies. And the policies determine how we automatically manage your service. So for example, you might say, I want at most 1/5 of my service to be taken off at one time when I'm upgrading it. And so we'll upgrade it in chunks of 20% of the service. You can say what sized VM you want to run on, whether you want 1 core or 4 cores or 8 cores inside of the VM. So all of these policies are expressed in the service model. You can also specify a set of configuration settings, and these are entirely up to you. They're designed by you and consumed by your code. So if you have connection strings or if you have timeouts or any other sort of configuration setting, you can put those into the service model, and that enables you to do a config-only update of your service. And then you don't have to update the code at the same time, so it's sort of a lower risk way of pushing out new configuration settings. And so now we've talked about the service model, and I'll jump back to the other picture, and I'll talk about what happens when we take this to the cloud. The first thing we'll visit, and I'll show you this in a few minutes, is this thing called the developer portal. This is a website that allows me to create services, deploy them, upgrade them, start them, stop them, and so on. And it also allows me to sign up for an account and choose what plan I want to use to pay for this. And underneath that developer portal, there's this service management API, which is a RESTful interface that's available to customers around the world. And it allows you to programmatically control your service. So you can deploy through a script, for example, using the service management API. The service management API, in turn, talks to our data centers around the world, and we have 6 of them today. I'll show you the list in a few moments. If we were to look inside of a data center, we would see the cloud fabric and cloud storage. Now, the cloud fabric is this distributed computation infrastructure that lives on commodity hardware around the world. There's a fabric controller. That's the thing I work on in my day job. And that fabric controller is responsible for managing the data center. So when a service is deployed in a data center, it automatically puts that service on the right set of VMs on these nodes. And we run multiple services and multiple role instances from each service across the sort of shared hardware pool in the data center. Now, production or cloud storage is also this highly available and scalable storage service that implements all of these storage abstractions in the cloud. And so we have that running. And we also have a global content delivery network. So if you have data that's publicly readable in your blob storage, for example, you can make that data available through our CDN, and then it's served from the edge to minimize the number of network hops to your customers. And that's in CTP today. So if I've got a Silverlight client running in a browser, I might communicate with a service that's running in the cloud, and I might also communicate directly with storage either through the CDN or talking directly to Windows Azure Storage. And so this is really the picture of Azure, and I'm not going to spend too much more time talking about Azure. I'll talk about some details as we talk about patterns. But I think this is really all you need to know in order to get started. So let's talk about patterns. I'll basically talk about 3 large patterns. Just how do we get Silverlight running in the cloud? How do we get Silverlight talking to Windows Azure Storage? And then how can we play with distribution of the computing power from the service running in the cloud to the browser? And then I'll jump into tips and tricks after that. So the first pattern is very simple. It's going to look a lot like it would look if we were to run something in an on-premises server. And I'm just going to demonstrate this too. So as I talk about it, we'll see where we go. So I can have some hosted application. Say it's ASP.NET. And it's got Silverlight built in. So there's a ZAP file that travels with it. And I run that in the cloud. And then my clients go to my cloud app and they access it. And this is basically exactly the same picture that you'd have on premises, except I can put it in any data center around the world. I can scale it up or down as much as I'd like, and that's very flexible. And I pay by the hour for each VM instance that runs in order to host this. And I also pay for network bandwidth in and out. And then it's extremely easy to deploy through this website. And so I thought what I would do is just show you this. So I'm assuming that many of you already have investments in Silverlight-based websites that you might consider moving to the cloud. So what I'm going to do is I'm going to create a Silverlight-based website, and then I'm going to move it to the cloud after I've first created it. And you will see that I'm in dire need of a creative agency to help me improve my Silverlight programming as we do this. So let's go ahead and create a Silverlight project to start. And I'll just go ahead and take the defaults. And I'm going to do a few things here. Rather than spend a lot of time on this, I will just do something very simple. Let's go ahead and create a button. And let's say, in honor of St. Patrick's Day. And then I'll go ahead and I'll just add some code to that. Okay, so before I run this, I'm just going to do one small thing. I'm going to run this on the cloud eventually, so let me just rename this test page to default.aspx, and I'll set that as the startup page. And now if I hit F5, I get the same experience that you'd always expect, which is this runs in the ASP.NET development server, and I get Silverlight running, and I can click the button, and it says Happy St. Patty's Day. Okay, so now I have my really fancy Silverlight website, and I'd like to move that to the cloud. So I'll go ahead and I'll just save this project, save the solution, and I'll create a new solution, which is going to be a cloud service. Now, usually when I create a cloud service from scratch, I would choose some roles to add to it from the list here. But since I already have the roles defined in my Silverlight project, I don't need to add any roles. So I'm just going to take an empty one. And then I'm going to add some existing projects to it. So let me go ahead and open up that Silverlight project that I created. So there's one part of it, and then I'll add a second part. And you can see that I have this role node over here. Now, I need to add the web role to this role node in order to get it to be included in my service model. So let me go ahead and do that. It's already in my solution. So I've added that here. And the other thing is that I created the Silverlight app using .NET Framework version 4. At the moment in the cloud, .NET 3.5 is what's available, 3.5 SP1. So I'm just going to switch to 3.5 so that this will work in the cloud. And there's a small bug that there's a Microsoft.C# dangling reference, so I'll get rid of that so that everything will work. And then the last thing that I'm going to do before I run this is I'm just going to go in and take a look at the service model. And so here is the representation of the service model that shows up in VS. And there's a bunch of stuff here. You know, I can choose my VM size. I can configure a whole bunch of things. For now, I'm going to do something very simple, which is I'm going to say instead of one role instance, I'm going to create 3 role instances, because I think I'm going to have a number of users who are going to access it, and I want to be able to handle that load. So let me go ahead and run this. And you'll see now that when I hit F5, something different is going to happen. It's not just going to run in the ASP.NET development server. Instead, it's going to run in the development fabric, and it's going to run 3 instances instead of 1. Now, on the client side, I should get exactly the same experience that I got before. I click this, and I get that button. But you can see down here I have the development fabric running, and I've already opened up that UI previously. And you can see here that I've got this deployment. This is a subset of the service model. I've got this contract for my external interface, which is an HTTP interface on port 80. And inside of my service, I've got one role instance, one role with 3 role instances running. And so this is in my simulated data center on my laptop. Okay, now that things are working on the development fabric, it's time for me to move this up to the cloud. So let me go back to Visual Studio, and I'll just go ahead and publish this. And what's going to happen now is it'll package up that application package that I talked about before, and it will take me to the developer portal where I can go and load this. So you can see here that this is the package, the code, and the service model. Let me just copy this path because I'm going to need this in a moment or two. And then over here, I've got the developer portal, and I'm already signed in with my live ID, and I've already signed up for a subscription. And so let me go ahead and create a new service. And when I create a new service, I have the option to either make it a storage service or a hosted compute service. And because I want to do hosted compute, I'll just go ahead with that option. And why don't I call this MIX demo? And I'll say Silverlight. Move to the cloud. And so I'll create this. And now I get to choose where I want this service hosted. And just to be adventurous, oh, first of all, I need a name. So why don't I call this Kerner Mix? That's probably available. Indeed it is. And why don't I just stick this in East Asia, just for fun. So I'll create this service. And now once the service is created, I'm going to deploy my application to this service. And so I'll use the application package that was created by Visual Studio. So here I have this slot, so I'm going to deploy in this slot. And first I will point my browser at the application package, the bits, and then I'll point at the service model. I'll just say my site in East Asia. So let's go ahead and deploy that. Deployment typically takes a minute or two. Here, once I upload the bits from my laptop to the portal's then got to push it to the Service Management API, and then it's got to push it to East Asia, so this can take a moment. And so while that goes on, I'll just mention that I really recommend that people spend a bunch of time with the development fabric. It's really quick to iterate there and tune things. And once you feel really good about it, then you can move it up to the cloud. And so that means you sort of have to wait for this period of time less frequently. The other thing is, once your service is running in the cloud, it's up there with all these different role instances. It's a little bit more difficult to manage individual instances if something goes wrong and you want to figure out what's going on. And so later on, I'll talk a little bit about this set of tools that are part of the SDK called Windows Azure Diagnostics that allow you to instrument your application in the cloud, and then you can collect traces and counters and events and IIS logs and everything else that you're used to using in an on-premises solution to figure out what's going on. So now I've got this deployed. Let me go ahead and run it. And usually it takes maybe 5 minutes for a service to start up because there are a bunch of VMs that now have to boot. And so I'm not going to wait for the 5 minutes to go by. I'm going to go back to the talk, and we'll come back here later on to see what's going on while that starts up. Okay, so I've just shown you this, and in about 5 minutes, I've written a service, I've deployed it in the development fabric, and I've now deployed it in East Asia. So now you can start to see, I did a whole bunch of work in Silverlight, and that's something that I do all the time, but I didn't have to spend too much time dealing with service management here. It was pretty easy for me to get something out there. So the next thing is, if you're really going to do an interesting application, it probably involves storage. There's some sort of data access pattern, whether you're just reading stuff and showing it to your users or whether there's some dynamic updates going on. And so I want to talk about how Silverlight and Windows Azure Storage can work with each other. And the first part of that is just talking about Windows Azure Storage. So as I said before, Windows Azure Storage is a highly scalable and available storage service that runs in each of our data centers around the world. It exposes 4 abstractions, one more than in the development fabric. I talked already about tables, I talked about blobs, and I talked about queues. There's also this concept of the Windows Azure Drive, and that allows you to mount a blob that's a VHD as a local NTFS volume on your role instance in the cloud. So if you've got code that uses local file system APIs to read and write your data, you can make that data durable. Of course, each of these role instances is running on commodity hardware. That commodity hardware could die. So you should think about local data in the role instance as just being a cache of the data that you store in some durable service. And so this sort of virtual disk that shows up as an NTFS volume is one easy way of making that cache into a durable drive. And of course, you pay per gigabyte stored and per gigabyte transferred over the network. And then you can do 10,000 storage transactions for a penny. So each time you do something, you pay for that too. So that's Windows Azure Storage. And you'd really follow the same pattern that you'd be used to following if you had a database and you wanted to make that available through a service on the web. You'd build the service, and the service would sort of proxy the data in the database. And so if we were to look at that in a picture, we would just add table storage to the picture that we had before, and then an ASP.NET or WCF-based service would proxy that table storage. Now, there's an API that's available for accessing Windows Azure Storage, and it's a REST API. There's also a .NET client library that wraps it. And you might think that with a REST API, you could just access table storage directly from the client side. But that might not be such a good idea for a couple of reasons. The first reason is there's a key that governs access to Windows Azure Storage. And that key is the key to the kingdom. If you have that key, you can delete data, you can create data, you can modify it. And so if you were to put the key into the bits on the client side, then any adversary with a debugger would be able to get access to that key, and then they would own your storage account. That's not so good. They could put a lot of data up there, and then you'd be paying for it. So we recommend not leaking the key to the client side. And even if you were to do that, you'd still have to deal with some cross-domain issues and some authentication headers that are not able to be set from Silverlight. So instead, you just follow the same pattern that you'd expect. But this idea of offloading direct access to storage on the client side is a very good idea when it comes to blobs. And blobs are a little bit different from tables. A lot of the times people will put images for their websites into blobs, or movies or music, and it would be inefficient for your service to proxy access to those blobs. They could be quite large. You'd pay extra costs in terms of latency and in terms of load on your service if you were the intermediary and if you were proxying all of that access. So we really recommend offloading to blob storage directly on the client side. And the way to do that is that you mark the container in blob storage to allow public anonymous access. And then anybody can go and just access your blobs using a URL, and that's for read access, and then you could just do things that way. And when you set things up that way, the CDN makes that content available, so you can serve from the edge, so you can get really great performance everywhere around the world if you have, say, a Silverlight app running in the browser accessing movies and video in the cloud. So it's a very similar picture to what we had before. I'll just add that you can actually move the ZAP to storage. And now the load on your compute roles running in the cloud is even further reduced. So you're just doing whatever dynamic processing is required and serving up, say, the initial page. And you should just remember that blob storage has a different URL. So if you'd like to serve content other than, say, just pictures and movies, which work by default out of blob storage, you should remember to drop a cross-domain policy file in the root blob container, which is just the root of the namespace, and make sure that that's publicly accessible. So there are also some scenarios where you don't want to make blob data publicly available to everybody. Maybe you've got paid content, so you only want to give it to people who've actually paid you. Or you've got free content that's subsidized by advertising that's shown on the same page. So you want to avoid people deep linking to the free content and sort of you're paying to provide this nice thing to them and they're not seeing your ads. Or you might have multiple users and you want to provide each user a view of their own files that you store on their behalf in the cloud, but you don't want to allow any users to see anybody else's files, and you don't want to have to manage, a billion different blob storage accounts. So what you can do is you can use these things called shared access signatures, and you might hear these referred to as pre-authorized URLs. And what that allows you to do is, in your service, you can generate a URL and sign it with the account key associated with that storage account. And then the Windows Azure Storage Service will enforce the access policy that's been configured by you when you created that URL. And you can hand that URL out to your clients. That's a very cheap thing to hand out because it's small and it doesn't take a lot of time to generate it. And then they can use that URL to access Windows Azure Storage directly. And Windows Azure Storage will enforce whatever policy you set for whatever duration of time you set. And so whoever has that URL can do whatever that URL allows them to do, and nobody else can. And there is a flavor of this that allows you to modify those access rights or extend or revoke the time period of validity dynamically from your service as you go. So this is actually a really flexible mechanism for using blob storage, sort of direct access from the client side without giving up the key to the kingdom. So just in a picture form, I start off with the same picture that I had before. Let's add in the account key that's in my sort of available as, say, a configuration setting in the cloud. And a client comes and asks for access to some piece of content, and I do something. Either I show them an ad or I authenticate them using whatever authentication system I'd like to use, and then I decide, okay, they're authorized to see that content. So I generate the shared access signature with a set of privileges that I want to give them, and I pass it back to them, and then they just go ahead and use it, and Windows Azure Storage enforces the rights. Now, I want to show some code somewhere in here so you can get a sense of what it's like to program with Windows Azure. So I'll just show you this, and it fits on one slide because this seems like something that could otherwise be intimidating. So the first thing that I'll do is I'll pull in some references to the libraries that I need to use for this. And then the second thing that I'm going to do is I'm going to get a handle to my storage account. Now what I'm doing here is this from configuration setting is going into my service model, and it's looking in the list of configuration settings that I defined, and it's pulling out the one whose name is storage account. And the value here is just a connection string, so it lists my account name, and it lists the account key, and it says that I'm going to be using HTTPS to access that account. And so now I've got a handle to the account so I can do things with the account. And the second thing that I'll do is I'll create a cloud blob client, which allows me to manipulate blobs under that account. And then I will get a reference to the specific blob that I'd like to access. And in this case, I have some container, which is paid content, and I have a WMA that I want to sell to somebody. And so now that I've gotten that reference, I'll set it aside for a moment, and I'll set up a shared access policy. And in that shared access policy, I'm going to specify two things. I'll specify the duration of time that I want to allow access for. Here I'm doing 30 minutes from now until 30 minutes from now. And I'm also going to say that they get only read access. They don't get to do anything else to this song. And then I'll go ahead and I'll get myself a URL that implements that access policy. And now I need to direct my end user to go to that URL. And this URL, it's not like anybody who has this URL can now read this blob. So I want to be careful about the way that I distribute it. Preferably, I distribute this over a secure channel. In this case, we might recommend using SSL to distribute the shared access signature. And you also might make sure that the shared access signature begins with HTTPS. So when the client then uses it, it will also be over a secure channel. And so there we are. That's shared access signatures in one slide. So I talked about running a basic site with Windows Azure, and I talked about storage access. Now I want to talk about the trade-offs with doing computation in the cloud versus computation in the browser. If you're doing things that are sort of data intensive, and I'm reading and writing data, I'm probably going to have a service running in the cloud. Or if I need to interact with some other back-end service, for example, I probably have a service running in the cloud. But some of the time, I've got a site that's basically content-oriented. And one of the beautiful things about Silverlight is I can do a lot of the computation associated with presentation on the client side rather than having the load on the server side. So as opposed to having ASP.NET, I might actually just have a really basic HTML page that instantiates Silverlight, and then all of the computation happens on the browser side. And everything gets served from blob storage. And the nice thing about this is blob storage is really highly scalable. So I could have a ton of people pounding my site. My role instances do very little work because they're just serving this static content. And all the computation's happening on the browser side. So as you design your applications, think about whether this pattern would work for you. And it can be really a convenient thing to keep the number of role instances small that you need. And you can just rely on Windows Azure Storage to provide everything. And you can, of course, use CDN if this stuff is publicly available. So it's a little bit of a twist on the previous patterns, but I think it's a nice way of using the power of Silverlight with Windows Azure too. So that's all I have for patterns. The remainder of the time that we have, I just want to talk about tips and tricks, because there are some things that if you know them, they're really easy. And if you don't know them, you can spend a lot of time trying to figure them out. And that's boring for everyone. So I have a couple of categories of tips and tricks that I want to talk about. And the first of those would just be general tips for dealing with the cloud. As I said before, it's really easy to start simple, just running things in the development fabric on your dev box. So do that a bunch, and once you have both development fabric and development storage going, you can make sure that your app is running the way that you want. And once you're happy with that, you can keep running in the development fabric, and you can now point at cloud storage and make sure that your data access patterns make sense in the cloud, and you're using the right account key, and it's all working. And once you get that, and by the way, when people do this, they often like to have several different storage accounts, one for test data and one for production data. So you can set up multiple storage accounts under the developer portal, and then just point to different ones depending on whether it's a test or a production instance. And then finally, you can move everything to the cloud. And as soon as you move everything to the cloud, you need to make sure that you can deal with problems when they happen in the cloud. If you see slow responsiveness or you see requests that are failing, you can use this Windows Azure Diagnostics piece of the SDK. And you basically just launch this diagnostic monitor that runs right alongside your role instances in the cloud. And as your role instances generate data, whether it's performance counters or traces or IIS logs or custom log files, you can gather that data with the diagnostics piece, and then you can upload that data to Windows Azure Storage, either on an automated basis every few minutes or on demand from your desktop. You can actually write an application that will request a data upload of a certain type of data. So if somebody reports a problem, you're kind of buffering the data locally in your role instances. You can say, hey, well, I need all of the traces from all of my role instances for the last hour in Windows Azure Storage, and then boom, it'll upload that from all of your role instances. The nice thing about using Windows Azure Storage there is that it's highly scalable. And so all of your role instances can submit a whole bunch of data. And then you can look those things over. And I gave a talk at PDC about how to use this. So if you're curious about this, you can go to microsoftpdc.com and find my talk. And I have a link to it later on. The other thing is people like to look at the contents of storage. And so there are a number of different storage explorers that are available. And I've listed a few here from different folks in the community. And there are many of them. And these are ones that I've used and have worked well for me. So feel free to check these out. In fact, some of these are now starting to build in clients for the Windows Azure Diagnostics stuff. So you can automatically look at your storage, and then you can automatically gather data. And you can also, even with some of these, deploy your application using the service management APIs. So it's sort of like a console for doing everything in Azure with this client tool. And then, again, I mentioned the service management APIs, and if you're interested in deploying things automatically, say as part of a nightly build process, you can go ahead and grab these PowerShell commandlets that are available on MSDN Code Gallery, or the tool called CS Manage that's available in the same spot, and I have links to those later. And then you can just build that into your automation, so you can deploy to the cloud automatically when you have new builds. So these are general cloud tips. They're not specific to Silverlight. Now let's go to some things that are starting to get more specific. I showed you before that if you're going to be using .NET 3.5, you need to make sure that you set that, and if you have that dangling reference to Microsoft.C#, remove it, and that's the same thing that I showed you before. If you're using MVC, I just want to show you this. There's a really easy way to use MVC. I'll go ahead and I'll create a new cloud project. And I can just take a role from here, and now I've got an MVC role in my cloud project. And I want to show you what it does, because it does this handy little thing for me. Under references, I've got system.web.mvc. And if I look at the properties on that, you'll see that copy local is set to true here. That's what gets this particular binary out to the cloud. And so if you use this way of doing things, it's just done for you automatically. If you have an existing MVC site and you want to move it to the cloud, just remember to set copy local to true so that it'll be up there. The next thing, I'll jump back again. If I go ahead and I create a Silverlight project, you'll see that I have a few different options for how to package that. The default is this web application project, and that works great in the cloud. The next one down is website. And the idea of website is that you can do sort of this in-place modification of your site on the server while it's running. That doesn't really make sense in the cloud because you have all these different role instances maybe running at different places around the world. So website doesn't work with the cloud, so just go ahead and use web app. And if you need to convert an existing website to a web app to run it in the cloud, people have done this. There are blog entries on how to do it out there, so feel free to check that out. And then you saw before that when I added some existing roles to a cloud project, I added them to the role node so that I'd have them in the service model. Just remember to do that, and then you can configure the number of instances that you want and the VM size and so on and so forth. And if you're going to add a cloud project to a different solution that you already have, if you don't set it to the startup project, then when you hit F5, it'll run in the ASP.NET development server instead of the development fabric. So just make sure that the cloud project is the startup project. So these are the few of the things that are useful when it comes to using VS and Windows Azure. Now, when it comes to Silverlight, the first thing is something that's just sort of a generic Silverlight thing, and it's useful to know. Let's go ahead and create a Silverlight project. And if I look at the web role that gets created, I look at the properties of that web role, and I go to this web tab, there are some checkboxes down at the bottom that configure the set of debuggers that I use, and there's this Silverlight one. If I've got this checked, I get Silverlight debugging, but I don't get JavaScript debugging. If I have it unchecked, I get JavaScript debugging, but I don't get Silverlight debugging. So if you want to debug both, you have to toggle back and forth. So just so that you know that. And there are two things that people sometimes forget to install. And then when they go to run stuff, it doesn't work right, and they get confused. The first is make sure that you have static content enabled in IIS. And the second is make sure that you have the Silverlight MIME type registered on your system. This all works magically inside of Visual Studio when you hit F5 in a Silverlight project because it runs in the ASP.NET development server. But when you use the development fabric, it uses full IIS. So you just have to make sure that these things are configured, or you'll have things not work on you. Finally, if you're going to use blob storage to serve data to the public, make sure that you mark the root container as publicly, anonymously accessible for read access, and also make sure that you add the cross-domain policy file if it matters in your scenario. And then finally, smooth streaming isn't supported today in Windows Azure, either from the roles that run in hosted compute or from Windows Azure Storage. We've heard loud and clear from many of you that that's important, so we'll keep looking at that. Progressive HTTP does work, and you can also use the CDN, so you can serve from the edge. Finally, if you're going to write a WCF service, which many people do when they use Silverlight, there are a few things you should know. The first category of things are not specific to Windows Azure, but they do come up in Windows Azure, and they come up in any scenario where you've got a load balancer. The first thing is that there are some flags that you need to set in WCF so that it works well in the load balancer scenario. That way, when a request comes in and the IP address in the request doesn't match the IP address on the actual node that's servicing the request behind the load balancer, WCF will accept the request. Otherwise, it naturally rejects it. The second thing is that, at least with Windows Azure and also with many other load balance scenarios, your connections terminate at the load balancer, and our connection timeout is 1 minute. So if you're going to have some long-running operation that won't send traffic back and forth for over a minute, your clients may experience timeout errors. So you should just think about that and consider asynchronous patterns in those cases. Or, of course, you could design your client code to handle these connection timeouts. But the asynchronous pattern is pretty nice, and it also works well in terms of scalability. Finally, there are some bindings in WCF where the client sort of continually pings the server. And this would be this particular one, this duplex HTTP binding, would be used if you had like a chat application or a stock ticker or something like that, where you want the illusion of server push, but it's the client that's doing the polling. And the assumption that this binding has is that there's affinity between the client and the server. And when you go through a load balancer, you won't always get affinity. So you might end up hitting, if you have more than one role instance on the server side, you might end up hitting multiple server-side role instances, and then it can get confused. So in that case, you need to store your client state locally and have all those backend, all of the role instances use that same client session state storage. And people have done this, and there are blog posts on it. Finally, in Windows Azure, we do one thing that is sort of special, and that is we map incoming requests to a different port. And so port 20,000 gets appended to each URI and a service reference when you take a service reference to a WCF-based service running in Windows Azure. And of course, that doesn't make any sense on the client side because the client is still talking to port 80 or 443 or whatever it is. So when you take the service reference and you get port 20,000, the easy thing to do is you just open it up and modify it. You just delete the 20,000 from the service reference, and then everything works. If you want to be really fancy, you can generate your own metadata in your WCF service and send that back to the client. And so that's also an option. And there's this page with all of these things described in gory detail. So if you are building a WCF service to run in the cloud, I recommend that you check that page out. All of this stuff has been tried and figured out, and so you don't need to spend time figuring out how to do that. I would be remiss if I did not mention several other services that run in the cloud that are available as part of the Windows Azure platform. The first of those is SQL Azure. So if you use a database, I really recommend checking this out. You go to a website, you click a button, you have yourself a relational database. It's highly available. You don't have to do any physical administration. It's actually really handy, and it works really well when you run in the cloud on Windows Azure. And so go ahead and check that out if you want to use a database with relational storage. And then there's Windows Azure Platform App Fabric, which contains two different key things. The first of those is this thing called Service Bus. And Service Bus allows you to connect an on-premises application with an application running in the cloud. And it does this securely, and it does this even if you have a firewall blocking off your on-prem stuff. And Clemens Vasters just spoke in this room in the last hour about that. So you can check out his talk for more details. It basically does like message rendezvous in the cloud for you. And it works really well with WCF. It just sort of magically works. And then there's access control. And access control is this solution if you've got customers who already have some identity solution deployed in their organization and you want to use that same identity solution in the cloud. This does federated identity and claims-based auth. And so you can just have them log on with their single sign-on creds, the same thing they use to log on to their computer in the morning, and that just works in the cloud. So depending on your scenarios, these may be very useful technologies. So you can certainly learn more about Service Bus from Clemens' talk, and then access control was covered in depth at PDC. And so if you just go to microsoftpdc.com and search for it, you'll find the talks on that. So let's just go back and check out the service that I put in East Asia. So here it's running. I've got 3 role instances up and running. And I'll just go ahead and click that, and I've tried this a couple. Wow, that was actually really fast to East Asia. It was much slower earlier today. So happy St. Patrick's Day from East Asia. And you can see, what I did was pretty simple, but now I've got this sort of automated deployment and management of my Silverlight website. I can scale it way up. If I decide I want 20 instances, I just go in, click the configure button, and change a number to 20, and then boom, I have 20 of them. And I can deploy it at 6 different sites around the world. And so it's pretty cool. It makes it really easy for me to just stop worrying about all of these things that every single service developer would otherwise have to slog through. And I can focus on understanding my customers and understanding my business model and making my service sort of unique and differentiated as opposed to just, oh, the server's down, oh, I got to patch the OS. So I think really Windows, Azure, and Silverlight are a great match. They really complement each other well. And it's really easy to get started. You can download the Windows Azure tools for Visual Studio for free, install them, run them, get a service running in the development fabric, get a service running in the cloud, try it out. We have an offer where you get 25 free hours a month until the end of June. So go ahead and sign up for that and put some things out there. And I'll be really interested to see what's there. And if you want more information, I have the mother of all further information slides here. The main link that you need to know is the first one, dev.windowsazure.com. But for those of you who want to dig into various topics, this deck will be available on the visit MIX10.com, so you can go get it and follow these links. And that's it. We have time for questions, or people can go home early. Yes?
Is there a projected time frame for .NET 4 to be available?
Is there a predicted time frame for .NET 4 to be available? I think you'll see that in the next couple of months. Yeah. Yeah. Other questions? Yes? Do you serve HTML pages from the blob storage? Indeed, we do. And you can play a little trick if you want to. You can actually put your entire site up on blob storage in the root container. The only trick is you have to get people to go to index.html. So if your domain registrar will redirect you to index.html, you can actually serve everything out of blob storage, which is kind of a cool scenario. But it depends on that little redirection thing, which is why I didn't mention it in the pushing compute to the browser section. But yes, it can be done. Yes? Well, so I mentioned before that there are some storage explorers. You can use them. You just open up one of those storage explorers and then take your cross-domain policy file and use those storage explorers to upload it to the root blob container. And then just mark the root blob container. Many of them have interfaces to set the ACL on the root blob container and just allow public anonymous read access. And then you're done, and it's up there. And there's nothing special. And also there are a bunch of blogs out there that talk about how to do this, so you can search for it and find it. But that's pretty simple to do. Of course, if you're just serving images or video, I believe that the Silverlight player doesn't care. It'll work. So it's only in some unusual scenarios, if you're doing deep zoom or whatever. Other questions? Okay, well, thanks everyone for coming.